Alright. So today we'll continue our last lecture for chapter 3. We will look on the angular momentum, and then we will do some of the tutorial for linear momentum as well. Okay, but before that, before anything, yesterday one of you asked me about the angle, the angle of the resultant force, is it? Betul Semalam orang tanya kan? Ke kelas lain kelas ni kan?
Betul.
Yes, sir. Saya tanya semalam.
Okay, I think I give you the wrong answer. Okay, you said this angle kan, yang with the x, this is the one lah actually. I don't know why I take this one. According to the equation pun, it should be Fy over Fx kan, and we know the tangent theta is opposite tentang bahagi sebelah kan, opposite bagi adjacent kalau awak belajar. Okay, saya belajar tentang bagi sebelah, saya belajar Melayu dulu. Okay, so it should be this one lah. You are right, you were right with yesterday. Okay, the angle should be this one lah. Tangent tentang dia ialah this one Fy, Fy over Fx lah, this one. So for this one, this is not Fy over Fx, this is Fx over Fy kan. So the angle is yang ni lah. So that's the correction I want to make. Okay. Let me allow sekejap, ada orang nak masuk. Okay, so I'm sorry for that. So now we can continue back our last subchapter, which is the angular momentum. Okay, this one. Alright, so yesterday we have discussed about linear momentum, and today the second one is the angular momentum. It's just benda yang sama, just a duplicate, but one with the linear velocity, and you in this one, in the angular momentum, because of that object, or in this case the fluid, is moving in rotational, dia bergerak, berputar lah, dia berpusing. So every all of the property will be in angular lah. You have your angular distance, you have your angular velocity, and you have your angular acceleration. And using that, you can find your angular momentum lah. Okay, if you look at this diagram, this circle, circle diagram, where your object is moving through along this circle, dia pusing, and this will create angular velocity, angular acceleration, angular momentum, and to find your angular velocity, with this one, W, is equal to the V, the linear velocity. The object still have the linear velocity, the tangent to this object. So this linear velocity divide by the radius. This R radius. So this will give you the angular velocity. Right? And you can the linear velocity in this one, and R the radius. And the this W is always expressed in revolution per minute. You have how many revolution dia berpusing, 1, 2, 3 or 4 whatever per minute, and is denoted by n dot. And to convert the RPM to radius per second, you can convert the revolution per minute to radian per second. 1 minute is equal to 60 seconds, and one revolution is equal to 2 pi. So that's why you multiply by 2 pi over 60. And to find the angular acceleration, macam sama lah, kalau your acceleration, your linear acceleration is just a velocity over t kan. Okay, in this case angular acceleration, so you have your the change in rate of change of angular velocity. So this at is your angular velocity, and t in time, so we use, because they move in rotational, so we use the radius lah. Okay, so at divided by r, right, to find your angular acceleration. Sekejap. Okay, so this is just due because the motion of all the point is in circle and the body move in circle, so that's why everything is in angular lah. Okay, so the angular momentum equation is used to solve many problems, engineering problems. Okay, there are a lot of application, a lot of instrument that move in a rotation kan, pumps, turbines and fans, so that's all application is in rotational motion kan, so that's why we need to use this angular momentum lah to calculate. Okay, so the angular momentum equation used to solve these engineering problems, but it's limited to steady flow condition. The flow inside is only for steady lah, you cannot use for unsteady flow condition. Okay, and by definition, the angular momentum equation is that the net force on the control volume during steady flow is equal to the difference between outgoing and incoming. Okay, so this is the definition lah, and to translate this definition into an equation, so the summation of moment, okay, equal to the outgoing minus the incoming. So outgoing momentum minus the incoming momentum, so you get that net force lah, or the net torque. Okay, so that's the angular momentum. As I said previously, angular momentum is something that is very rare come out in your exam or your test, but it's still in your syllabus. Okay, so that's why we still need to know how to solve this problem. Maybe this year or next, maybe who knows, this year ke akan keluar, so you need to prepare lah. Okay, don't just ignore this subchapter, it's still in your syllabus and they can ask you, okay, about this problem. So that's why I still give you one example of this angular momentum. Okay, and bending moment acting at the base of a water pipe. Okay, we look at first example. So underground, this is underground, under typo. Underground water, okay, is pumped through a 10 cm diameter pipe. Okay, the water is pumped through underground, goes up into this pipe, and 10 cm diameter that consists of a 2 meter long vertical. So the panjang pipe ni 2 meter vertically and 1 meter horizontally, as shown in figure. So water discharged to atmospheric, so the water comes out to the atmosphere at an average velocity of 3 meter per second. Okay, so that's why it says average velocity. Remember that we know that the velocity of a fluid is not uniform. Okay, that's why we need to use this dimensionless correction factor kan, beta. Okay, so that's why when they say it just average, so they just put just take average of that velocity lah, so they don't give you any value for the beta kan. So you can use the 3 meter per second, the average. And the mass of the horizontal pipe section when filled with water, okay, the mass of this horizontal pipe, yang ni, on the pipe ni, okay, they said when filled with water is 12 kg per meter. Okay, so they has a mass, or you can translate in W, and this mass they give you 12 kg per meter, 12 kg per meter. Okay, per meter. So for this 1 meter, so the mass will be 12 lah. Okay, because the length is 1 meter kan. So the mass is 12 kg lah. Okay, for 1 meter. Right. The pipe is anchored on the ground. So this is where the pipe is anchored on the ground at point A, kat sini, by a concrete base. So you have your concrete base. So this concrete base anchored this pipe. Determine the bending moment acting at the base of the pipe point A. So they ask you to find bending moment acting at this point, point A, the moment, okay, and the required length of the horizontal section. So they ask you to find this required length of the horizontal section, okay, that would make the moment at point A is 0. Okay, so they ask you two things. First, to find the bending moment at this point A, and after that they ask you to find this length, horizontal length of this pipe, or this horizontal pipe, in order to make this moment is 0. Okay, so just two different question lah. Okay, so this is just assumption lah. The flow is steady, apa semua, the row of the water 1000. Alright, so this is the question. You need to understand the question first. Okay, so you draw your FBD at your diagram. So you have the velocity comes in, so this inlet, okay, ke bawah ni, and you have your pressure, okay, P1, A1 comes in as well, and you have M dot V2 yang keluar, okay, to the right, okay, and you have your W, okay, W to downwards. Okay, and it says here the conservation of mass equation, because of this pipe is apa, similar cross section, the cross section of this pipe is same, so the velocity will be the same lah, velocity comes in and comes out is the same, and that's why the mass flow rate will be the same. Okay, the continuity equation tu sama dah, Q pun sama, volume flow rate pun sama, mass flow rate pun akan sama, because the V sama, A sebab A dia constant kan, the area of that pipe is constant, so that's why it's easy, the V, everything will be the same. Okay, and you can find your mass flow rate, okay, the mass flow rate using your continuity equation. Okay, I hope you still remember this, rho times A times V, or rho Q. Okay, this also rho Q kan, sama lah, rho Q or rho times A times V, and you have the rho of the liquid, the water is 1000 times the area. So they give you the diameter of the pipe, so you can find the area pi r squared or pi d squared over 4. Okay, in this case pi d squared over 4. And the V, okay, the V, they give you the velocity is equal to 3, so you can find your mass flow rate, alright, 23.56 kg per second. Okay, we need to find this mass flow rate because we will use this value inside our angular momentum equation again. That's why we find the mass flow rate lah. Okay, okay, then they give you the W, okay, they give you the mass of that pipe with water, 12 kg per meter, and this is 1 meter. In this question, the length of the horizontal pipe initially, okay, 1 meter. So we know the mass will be equal to 12, and if you times G 9.81, you will get your W lah, W downward kan, acting downwards. Okay, so this W we have value 117.7. So this W will have a moment clockwise lah, from point A. Okay, so they have will create a moment at point A clockwise. Okay, so that's one. Okay, to determine the moment acting on the pipe at point A. Okay, at point A we need to take the moment of all forces. Okay, that we need to take note all of the forces, W, the mv squared ni, m dot v2, okay, and m dot v1, okay, and this moment about point A lah. Okay, so this is a steady flow problem, so you need to write your angular momentum equation, summation of moment, okay, equal to the radius. Okay, these are the radius. Okay, times the mass flow rate times the velocity out and in, and minus the in. Okay, so R is the average moment. Okay, this distance of the moment. Okay, the V is the speed. Okay, the velocity. Okay, so you take that all moments in the counterclockwise direction are positive, so you need to establish your which one is the positive. So in this case, they take the counterclockwise. At point A is positive, so the clockwise, yang clockwise semua negatif lah. Okay, so you write all your momentum equation. Okay, you have your MA. Okay, counterclockwise positive. Okay, minus R1W is this one. Okay, so this will create the clockwise moment. That's why it minus R1W. Okay, and equal to you have the MV out, MV2 ni yang out, and the length of that is this one, the R2. Okay, so this will create moment clockwise juga. Okay, that's why it's negative. Okay, so you write all your equation in your linear in your angular momentum equation. Okay, to find your momentum ni, and you rearrange your equation, put your this to the right. Okay, bring R1W to the right. Okay, and replace all the value. So you know R1 is 0.5, this one 0.5, and you have W. You calculate the W already here, 117.7. Okay, minus the R2, 2 meter. Okay, M dot, you already calculate the M dot, 23.56, and V times V, the velocity 3. So this will give you the moment acting at point A, and the value is negative. Okay, again, don't worry about the value, the sign, whether it's positive or negative. In this case, when you calculate, you get the negative. That means this moment should be acting like this lah. Okay, not counterclockwise. Okay, so just the assumption of the direction is wrong. Okay, it should be acting in clockwise direction. So that's the first question. Okay, to answer the second question, where they ask you to find the length of this horizontal pipe in order to make sure this moment at point A is 0. Okay, so in this case, the MA now is 0. Okay, so that's why it equate this MA to 0. So 0 equal to R1 times W minus R2 times M dot V2. To find the length, okay, so you need to change the R, okay, in term of length, the R1, so this R1, they gave you initially in the question the mass of this pipe and water is 12 kg per meter, kan, 1 meter. Okay, so that's why you have the radius where the W acting in the middle, kan. So that's why you have the R1 is 0.5. So that's why it comes here 0.5, because 1/2. So W is acting in the middle. Okay, so that's why you already calculate that W over L is equal to 117.7 Newton per meter length, W. So you can change the R1 here equal to L over 2 lah. Okay, ni kan R1 ni sama je dengan L over 2, kan. Okay, so the length of this pipe, okay, 1 meter over 2 will give you the R1. Alright, so that's 1. Okay, you change the R1 equal to L over 2, and you know that this W, okay, this W, the weight, because they give you the weight equal to 12 over 1 meter, kan, 12 kg per 1 meter length. Okay, so this big W is equal to the W times the L, and the L, this is L. Okay, this is the mass. Okay, mass kecil, and this so W kecil times the L besar, okay, will give you the W lah, the what you have found before kan. You can change this W besar equal to apa WL lah. So W besar ni, W besar ni 12 kg ni, okay, equal to W kecil times L. Okay, so this will be W kecil times L. You can change this W in term of L as well. Okay, so that's why you get here R1 equal to L over 2. Okay, and the W equal to L times W. L times W. So that's why you have L squared W over 2 minus R2 mass flow rate times the velocity 2. So this one you need to change that because you want to find the length horizontal kan. Okay, so you have the value for this. So you rearrange this equation to find L. Okay, because you have L squared, so that's why it is set. Okay, set to R2 m dot V2 over W lah. Okay, and you can replace all the value inside the equation. 2 times 2, and the R2 is 2 meter times the m dot times the V, and divide by the W that they gave you, 7.7 Newton meter per meter, and you will get the length of the horizontal pipe, where this length 1.55 meter, and when you have this length, this moment at point A will equal to 0. So there's no net moment lah acting at point A. Okay, so that is one example lah for angular momentum equation. Okay, I just show one because it's not very famous in the question, but you need to know this thing, this topic. Let's say this year they come out in your test or exam, you know how to do this. Alright, okay, boleh? Okay, now we move to the tutorial on the linear momentum equation, because this is what most commonly asked lah in your exam. Okay, so that's why I show you few example. Dalam ni ada 1, 2, 3, 4, 5, 6, 7, 8. Maybe we look lah mana-mana kita sempat. Okay, if we sempat to cover all, we cover all. Okay, alright. So the first question about the linear momentum application. So a part of a piping system used to deliver oil. So they gave you the specific gravity of oil. So you can change this. Okay, you can change this in term of rho lah. That's times 1000. To a refinery in Pasir Gudang is shown in figure 1. The reducing pipe band has a 150 mm diameter at section A and 100 mm diameter at section B. So the cross section of this pipe is not constant. Okay, you have a bigger inlet and smaller outlet. Oil flows through the pipe band at section A with a velocity of 3.2. Okay, this is your velocity 1. Okay, and a pressure of 150 kilopascal. So this is your pressure 1. Okay, neglecting the elevation difference between section A and B, so they ask you to neglect Z1 and Z2, even though in this section, in the diagram, you can see the difference lah. Because there's one point here, and then the point is here, so should be have some elevation difference, but they ask you to neglect. Okay, determine the pressure reading at section B. Okay, they ask you to find the P2. Okay, and the resultant force required to hold the pipe band in place. Okay, they ask you to find the resultant force. So you need to find the Rx and the Ry, and you can find your resultant force lah. Okay, alright. From the question, you know, so they give you the diameter. You can find your diameter, the area for A1. Okay, A1 equal to pi times 150 bagi 2 lah 75 kan. So 75 0.075 square. Okay, so this is your area 1, and you have diameter 2 as well, so you can find your area at point 2. So this will be pi times 100 bagi 2 50, so 0.05 square. Okay, so why you find the area? Because you want to find the velocity kan, using the continuity equation. So first, continuity equation, okay, they give you the V1, okay, the V1 yang masuk, okay, V1 yang masuk, and you have your V2 yang keluar. Okay, so don't forget to label all your velocity and also all your forces lah in your FBD kan. And they said you have pressure 1 masuk, so in term of force P1A1 lah. Okay, inside, and you don't have the P2, okay, because no, you have the P2 because it doesn't mention that it's released to the atmosphere. So you have the P2, okay, against this volume, okay, P2, okay, and because of this angle, so you need to know, okay, you have V2 cos theta, enable, and V2 sin theta, okay, and you have your P2 cos theta and P2 sin theta bawah. Okay, so this is all your forces and your velocity. Okay, to find V2, because they give you the V1, you need to find the V2, and this is very easy, just A1 V1 bagi A2 lah kan. Okay, so A1 is pi times 0.075 squared over pi. A2 is 0.05 squared. Okay, times V1 is 3.2. Okay, so you get your V2 lah. What is the value for V2 here? 0.075 squared over 0.05 squared, darab 3.2. What's the value for V2? Anyone can calculate?
Sekejap.
Okay.
Seven point two
7.2 7.2 meter per second. Okay, so you need to calculate this because they ask you to determine the pressure reading at section B kan. So what equation that you will use to find the pressure again?
Bernoulli equation.
Bernoulli equation, yes. Bernoulli equation equal to P1 over rho G, I hope you remember this, plus Z1, okay, plus V1 squared over 2G equal to P2 over rho G plus Z2 plus V2 squared over 2G. Okay, and they ask you to neglect the difference in elevation, so this will be 0. And so you have the P1, okay, because you want to find P2 kan, okay, and you have a V1 and a V2, so this can be rearranged in terms of P2. So P2 will be equal to P1 tambah V1 squared minus V2 squared over 2. Okay, this will be times rho. Rho G potong untuk P1 and G for V2 potong, so just times rho. Okay, so this will be, so they give you the P1 in the question 150 kilopascal, Okay, don't forget the kilopascal. So this will be 150 times 1000. Okay, 1000. Okay, plus V1 squared is 3.2 squared minus V2 squared. So that's why you find the V2, 0.2 squared over 2, and the rho of the oil given in this question. So this will be 860 lah. Okay, and you will get your P2. Berapa nilai P2 then? Okay, berapa nilai? Ada yang kira? Calculate.
132 112
Apa? 1
32
132
12
12
112.
112. Okay, 112. Unit? Apa unit?
Pascal.
Pascal, don't forget your unit. Okay, so this is the answer for 1 lah. Okay, to find the pressure at point 2. Okay, next. Okay, so this is the answer. Sama lah 132.1 kilopascal kan. You just divide by 1000 So next you want to find the resultant force kan. So you need to find the resultant force in x direction and also in y direction. So using the linear momentum equation, okay, third step, using linear momentum equation. Okay, so you have summation of force x equal to rho times q, okay, times v2x minus v1x. Okay, and you need to establish your reference axis, and in this case they give you to the right is positive. Okay, okay, so again I label the force in this diagram. So you have your P1A1, P1A1, okay, and you have P2 masuk sini. This is P2, so that's why you have this is P2 sin theta, and you have P2 in x direction, P2 cos theta. Okay, so the theta is here kat sini, 30 ni kat sini lah. So they give you the theta 30, so the theta is here 30. Okay, so and then you have your Rx lah, Rx you apa, Rx ni you set in the with the same reference axis to the right lah. Okay, so you add all of this force. Okay, so you have P1 A1, okay, this summation of force in x direction again, and you have the Rx, okay, the one that you want to find apa resultant force in x direction, and you have P2 cos theta, and this is in the opposite direction to your reference. So that's why you minus, okay, P2 sorry, ni P2A2 not P2 cos theta, P2A2 to find the force kan. So sama lah P2A2. Okay, P2A2 cos theta. So this will equal to rho Q and V2X. Okay, you have the V2 out. So you have your V2 out, and this is V2, and in X direction, so this is V2 cos theta, and in Y V2 sin theta. Okay, so you have V2X is V2 cos theta. This direction is similar to your reference. So V2 cos theta minus V1X is V1 lah. Okay, because V is V1 masuk in X direction, just V1. So direction is the same with your reference, so just minus V1. Okay, so this is your equation, and to find resultant force in S direction, so you just bring everything to the other side. So this will be rho times Q times V2 cos theta minus V1 plus P2A2 cos theta minus P1 A1 theta. Okay, so just put back, check your the data for all of these property. So you have your rho of your oil is 160 and Q, so you need to find the Q lah. Okay, from this continuity equation. Okay, Q will be equal to A times V kan, A1 times V1 or A2 times V2. So A1 pi times 0.075 squared times V1 times 3.2. So berapa dapat kat sini? Pi 0.075 squared darab dengan 3.2. Berapa nilai Q awak? Berapa Q? Volume flow rate?
Kosong 0.0565.
0.0565. Okay, so this value will be used in our linear momentum equation kat sini. Okay, P times Q 0.0565. Okay, and times V2 is apa V2? 7.2. Okay, 7.2 cos 30, the theta is 30 minus V1 is 3.2. Okay, plus, okay, P2, you already calculate the P2 132112. Okay, 132112 times A times A2. A2 is pi times 0.05 squared. Okay, pi times serambut bawah ni 0.05 squared. Okay, cos theta cos 30. Okay, minus P1, they gave you the P1 150,000. Okay, so 150 kilopascal times A1. A1 is pi times 0.0075 square. A1 okay. Alright, so very long. Okay, what is the answer for Rx? Ni, just follow this 860 times ni plus ni minus ni. Berapa jawapan dia?
negative 1604.42.
1604.4.
0.42.
The unit is
Ini result to force.
force apa?
Force Newton per meter. Kau kan.
Ni- apa?
Pascal kot.
What is this RX? What you calculating here?
Force. Result to force.
Force apa?
Newton.
Newton lah. Okay, so just Newton lah. And apa? You get negative. Okay. So as we discussed yesterday, this negative shows that this resultant force in x direction should acting ke sana lah not the first assumption that you make this one. Okay, so or the answer can be right as 104.4 Newton in that direction. Okay, so your resultant force in x should acting towards to the left. Okay, so this are x. Okay, they ask you to find the resultant force. That means you need to find for y lah. So for y, and they give you the reference as this. Output is positive. Okay, so this will equal to rho q times v2y minus v1y. Okay. So you have the term in the force term in y direction is only 1 ry. Okay. And you have P2A2 sin theta to the opposite side. So you can write your force only ry because P2A2 sin theta is in the opposite direction to your reference axis. So that's why you minus P2A2 sin theta A2A, and this equal to rho times q. V2y is this one, V2 sin theta in the same direction. So you have your V2 sin theta, and in number for V1 there is no V1 only is cos 90, so 0 lah. Okay, so to find Ry, the force in y direction, just bring to this one to the other side. So rho q times v2 sin theta plus p2a2 sin theta. Okay, so what is the value for resultant force in y direction here? Just put rho 860 times q 0.0565 times v2 sin theta is 7.2 sin 30 plus p2. So you already calculate the p2 is 132112 times a2 pi times 0.05 square sin 30. Berapa dapat kat sini jawapan dia? Saya tak tulis saya tulis value, saya tulis ni je. Awak masukkanlah value dia dalam ni. Okay, berapa value dia? Ry diorang kira tak? What do you get for RY?
It's 93.86 kot.
Berapa again?
693.86.
693.8. Okay, did anyone get the same? Ada yang lain dapat yang sama? Positif ke negatif? Positif kan?
Sama.
Okay, sama. Okay, so you get positive, so that means this assumption to the upward positive is right lah. Okay, so your RY you're acting towards your reference axis and so we're not finished yet. So they ask you to find the resultant force, so you need to find the resultant force at the FR is equal to the Rx that you have already defined squared plus Ry squared and set of this. Berapa nilai dia? Dapat sama tak dengan ni? 1748.2. And this squared plus this squared, set of them. Did you get 1748?
1747.9.
1747. Sama lah
.9.
There's additional places lah yang berbeza. Okay, so this is your final answer lah. Okay, resultant force. Okay, so this question normally will give you 12/12. So if you can answer this question correctly, you get 12 mark. That's a very big mark lah. Okay, any question for this first example? Before I move on to the next one. Tak ada? Okay, good. Kalau tak ada, I assume you understand how to solve this. Okay, next example. Water in the nozzle is pointed to the wood block as shown in figure U3B. Okay, this figure lah. So the inner diameter of the inlet pipe D1 is 0.3 meter and 0.15 at the outlet. So they have bigger inlet and smaller outlet. This is a nozzle. So the nozzle discharges water into the atmosphere at point 2 and strikes the wood block at point 3. Okay, after this discharge and this water strike this wood block. The total weight of nozzle and water is negligible, so that's why it says here. So you don't have your W lah. Okay. Determine the resultant force exerted at the elbow kat sini and forces needed to prevent the wood block from moving horizontally due to the water stream. So first they ask you to find the resultant force yang acting kat elbow and another one yang acting dekat this wood block. Okay, to prevent this wood block from moving. Okay, and they give you the P1 equal to 1.5 kilopascal and V1 equal to 1.524. Okay, so first from the continuity equation, from continuity equation, you can find your V2 lah kan. Okay, because they give you the A1, you have your A1, you have your A2. Okay, from this you have V1, so you can find your V1, V2 lah. So V2 will equal to A1 pi times A1 pi times 0.15 squared. Okay, bahagi A2 0.075 squared times V1 is 1.524. Okay, so what's the value for V2? Apa nilai V2? Ada yang kira?
0.096.
6.096 meter per second. Okay, that's one. So you get your V2. Alright, so you will use that V when you want to write your linear momentum equation kan. Okay, so first you need to label all the forces inside this diagram. So you have a V1, okay, and you have a V2 comes out, and you have P1, okay, P1 masuk, ada P1 A1, okay, and you don't have a P2 because this is discharged into the atmosphere, okay, and you have your Rx lah, so you did your reference axis, the Rx is in positive to the right, okay. So to calculate the resultant force at this elbow, so you take point 1 and point 2 lah okay, so point 1 and point 2, okay, so your equation to the right is positive, so summation of force in x direction, okay, equal to rho times q times v2x minus v1x kan, okay, and add all your force term in x direction. You have only Rx lah, you don't have a P2A2, so it's only Rx lah, so Rx equal to rho q times v2x is the v2 and the same direction, so this is v2, and v1 is 0, so you don't have that, so it's only v2 lah, okay. So easy. So rho of this water is 1000, and the q, did they give the q? No, so you have to find the q lah from the continuity equation. So q a1 times v1, a1 pi times 0.15 squared times 1.524. Berapa nilai Q? Pi times 0.15 squared times 1.524. What's the value for Q?
0.1077.
0.1077. Okay, so put back in this equation 0.177 times V2, so you have your V2 6.096, okay, and this will give you the resultant force in x direction. Berapa nilai ni? Berapa? Thousand times 0.1077 times 6.096.
656.5392.
656 point
5392.
5. Just adjusted one mana sebab panjang Okay, so this is your new your resultant force in x direction, and you need to do the same for y. Okay, positive upwards, positive y equal to rho q and v to y minus v1y. Okay, and you have the force term in y, so you have p1a1, this one in y direction, Okay, so this positive P1 A1, P1 A1 plus you have the RY lah. Okay, RY in some in your this reference exist, so plus RY, and that's it. So equal to rho Q V to Y is 0 and there's no V to Y, minus V1Y, so V1Y is V1, so this is V1 lah. Okay, so RY will equal to negative rho times Q times V1 minus P1 A1. Okay, so berapa nilai RY?
Rasa
Ya,
kenapa yang row Q V1 tu dia negatif?
rho Q this ni kan yang tolak V1 kan?
Okay.
So that's why negative lah. Okay, put everything inside. So rho 1000 times Q 0.1077 times V1 is apa V1? 1.524 minus 24 minus P1 is 1.5 times 1000 times A1 is pi times 0.15 square. So berapa nilai RY? Apa? Resultant force in Y direction. Anyone yang dah kira? Boleh cakap, tak semestinya orang yang sama siapa je yang dah kira? What's the value for RY?
Negatif 270.6.
270.6. Okay, so again this is negative 270 270. Okay, negative, that means your RY, this direction is wrong, it should be in downward direction okay, so don't worry about the sign. And they ask you to find the resultant force okay, so you need to add lah both of these and the Rx and Ry. Okay, so the resultant force should be 656.5 squared plus 270.6 squared. Berapa nilai resultant force? Siapa dah kira? 656.5 squared plus 270.6 squared.
710.04.
710.04. 710 lah. Betul. So this is your answer lah for resultant force. Okay, so this one 711 sama lah so you get 710. Okay, just decimal place and they also ask you to find the force yang ni the force exerted at the elbow, so we have done this, and the force needed to prevent the wood block from moving. Okay, who can just guess apa kalau tak kira pun awak boleh teka dah berapa nilai dia. Berapa nilai yang RX ini? Force yang acting on this block. Who can guess?
65.4.
Oh, dia apa? It's not fair. is the same with ni lah betulnya yang ni. 656.5 ni why? Because this one you calculate the RX this one kan? Betul tak? You calculate the force in X direction this one, and to make sure this wood block is not moving, so you need an equal force acting against this force kan? Okay, so that's why the value should be 6.5 juga lah. Okay, ni mungkin apa sama lah decimal places so but to confirm that, okay, to confirm this value, so you take 0.2 and 3 kat sini, 0.2 and 3, so 0.2 and 3 so you do the same summation of force in X direction, so to the right is positive, okay, Fx equal to rho Q times V, so V3x minus V2x. Okay, so your force is so you want to find ni kan this half x yang letak sini, so you only have this one, so this is negative Rx, okay, equal to rho Q, V3x is 0 and V2x you have a V2x lah, okay, in the same direction, so that's why just minus V2x to 0 minus V2 lah. Okay, so you have minus Rx equal to minus rho Q V2. Okay, so you can cancel out the minus, you can calculate from this rho, your rho 1000 and your Q, okay, your Q is this one sama lah dengan ni rho Q V2 rho Q V2 juga kan. Okay, so the answer should be 656.5 lah. Okay, 656.5 and this direction you assume ke sana and this is positive, so that means your assumption is right. So this is the value for resultant force exerted on the wood block. Okay, boleh faham tak ni? Any question regarding this? Tak ada?
Kalau dia memang release ke atmosphere, memang tak ada P2A2.
Tak ada P. P2 tu kosong lah. Betul. Okay, soalan ni dia yang first tu kita ada P2A2 kan? This one you have a P2A2 value because this this part is not mentioned that this go out to atmosphere. So they just take one part of this pipe, okay, and they ask you to find the resultant force. Okay, different with this one. So this one it says the water is discharged into the atmosphere. So you don't have any pressure 2 lah. Okay, when it's released to the atmosphere, the pressure is 0. Okay, good question. Any more? Tak ada? Okay, we can move to the next example. Again, this is 12 mark. So it's very high mark. So that's make sure you know how to solve it. Okay, do step by step. Again, like the procedure. And then you should able lah to answer the question. Okay, next one. the water flow at rate of 65 liter per minute, and so this is your Q, okay, volume flow rate through fully open tap as shown in the figure. The inner diameter of the inlet pipe is 3 cm, this D1, okay, and D2 outlet is 2 cm, and D2. The tap discharge water into the atmosphere. Again, it says here, so you don't have the P2 lah. The elevation difference between the center of the outlet and outlet ni dengan the inlet is 5 cm. So they give you this elevation difference, the Z. The total weight of tap and water is negligible, so there is no W downwards. Determine the gauge pressure at the center of the inlet. So they ask you to find the P1. And the anchoring force Fx and Fy needed to hold the tap in place. So they ask you to find the Rx and Ry. Some ikut reference ni lah. Okay, to do this again, first step by step. So you need to label all your force. Ada V1 masuk, okay, and you have P1A1. And you have a V2 yang keluar, V2. So because you have this angle, so you have V2 cos theta and V1 sin theta. This V1 sin theta and V2 sin theta, cos theta, sorry. Okay, V1 ni tak ada. So that's all your forces. Okay, and now you can start solve your problem. So they give you the Q. The Q is 65 liter per minute. Okay, you need to able to change this into meter cube per second. So to change this, so 1 liter and times 1 minute. Okay, so 1 minute is 60 seconds. Okay, so you can solve the minute, and 1 liter is 0.001 meter cube. So you can cancel out the liter. So this will give you in meter cube per second. Berapa nilai ni? 65 times 0.001 bahagi 60 divide by 60. So what is the value for your Q? Berapa nilai Q? Anyone? Yang dah kira? Just say the value for Q. Berapa nilai Q?
One point zero eight
1.08
times 10 to the power of negative 3.
10 to the power of minus 3.
Minus 3.
Okay, so this is meter cube per second. Okay, and you can find your A1 and A2, and they give you the diameter of A1 and A2, so you can find the V1 and V2 lah. Okay, so V1 is equal to A1 is pi times 3 bagi 2 apa 1.5 kan, so 1.5 apa pula aku gunakan, sorry, you want to find the V Q over A sorry, so Q is 1.08 times 10 power minus 3 divide A1, so A1 is pi times 0.015 squared. This is V1. Okay, berapa V1? And V2 Q bahagi A2. A2 is by 0.01 square. Okay, what's the value for V1 and V2?
V1
Mm-hmm.
1.5 to 8.
1.5 to 8.
Yeah.
V2
3.438.
3.438.
Yeah.
Okay. Okay, so you got your V1 and V2. So now, how to find the P1 using the what equation?
Bernoulli equation.
Nanti say P1 over rho G, okay, plus Z1 plus V1 squared over 2G. This one equal to P2 over rho G plus Z2 plus V2 squared over 2G. Okay, so you will get P1 lah So P2 is 0. Okay, and you have Z1 minus Z2. Z1 minus Z2 is 5 centimeter. Okay, so Z1 minus Z2 will be equal to 0.05 meter. Okay, so you have V1 and you have V2, so you can find P1 lah. Okay, so P1 equal to berapa kalau awak boleh kira? And V2 squared over 2G minus V1 squared over 2G, and then minus Z1 0.05, and then times rho water times G. What's the value for P1? Z2 ni kosong lah, okay? Z2 ni kosong, Z1 ni 0.05 kan. If you take your reference point apa yang bawah sekali, okay, this is 0, so this is 5. Okay, so Z1 is 0.05. Okay, siapa dia dapat jawapan dia? P1 dapat tak sama dengan ni? P4290.3. Dapat?
Saya kira dapat 4252.03.
4252. I think it's just the nilai decimal places yang apa jawapan dia ambil mungkin dia take 1.53 and 3.43. Okay, depends lah. So this is the right answer lah even though it's not the same with this one. So because of that decimal places so don't worry about that. Okay, so P1 is 4252. Apa unit dia? Pascal lah.
Okay.
Okay, so that's settled for question 1. And then they ask you to find the anchoring force. Okay, anchoring force Rx and Ry lah. Okay, using the linear momentum equation. Okay, summation of fx. So this is positive, so your reference to the x to the right is positive. Okay, fx equal to rho times q times v2x minus v1x. Okay, so you have the force in x direction is P1A1. Okay, and you have your Rx lah. Okay, so P1A1 plus Rx equal to rho Q. Okay, V2X is this one. So you have your V2 comes out, so X V2 cos theta. So V2 cos theta minus V1X is V1. Okay, so minus V1 lah. Okay, so you can find your Rx will be equal to rho times Q times V2 cos theta minus V1 minus P1A1. Okay, berapa nilai Rx? Okay, the rho of water 1000 times Q. Q is 1.08 minus 3. Okay, V2 is 3.438 cos 80 minus V1 1.528 minus P1. So P1 is P1 oh ni 4252. Okay, 4252 times A1. A1 is pi times 0.015 squared. Okay, what is the value for Rx then?
Negative 4.01.
Negative 4.01 Newton. Okay, so this is same answer lah. So this negative, again, so the Rx should x to the opposite line. It's not in your reference axis to the left. Okay, so that's one. And they ask you to find Fy, so do the same for Fy. So output is positive. Fy equal to rho times Q times V2y minus V1y. Okay, and force in y direction, so you have only Ry lah, so only Ry. So Ry equal to rho 1000 times Q is 1.08 times 10 to the power minus 3 times V2y. Okay, you have V2y is this one, V2 sin theta, and this is opposite direction to your reference, so minus lah, minus V2 sin 80 minus V1y. There is no V1y, so minus 0 lah. Okay, so what's the value for Ry then? Did you get the same with minus 3.68?
Negative 3.66.
Okay, so because so negative 3.66 Newton. Again, this negative, that means the Ry should acting downwards, not upwards. Okay. Alright. Okay, you can write this answer. You can leave this answer like this, or you can write like 3.66 and acting downwards. Okay. Any question? So this again 12 mark. Is it easy or difficult? Senang ke susah? Tak ada orang jawab. Tak berani jawab senang. Is it difficult? Susah kan?
Agak susah ni.
Kat mana yang susah? Maksudnya awak tak understand. Kat mana susah?
Tak, saya kena kena try banyak sekian sikit.
Kena try banyak. Of course lah, you need to do the tutorial But if you follow it's just writing your equation lah. Okay. It's maybe difficult because you have a lot of the equation is quite long, but it's not something that complicated. Okay, just follow what's your term in x direction and also in y direction. That's it. Okay. Alright. So can we move to the next question, or do you have any question regarding this problem? Ada siapa nak tanya pasal ni? Anything?
Sir,
Tadi
sir ada tulis Z1 tolak Z2 kan? Yang tu apa tu?
Z1 tolak Z2. Sekejap. This one. Ni, kat sini. Okay, kenapa? Soalan dia apa?
Yang sir tulis Z1 tolak Z2 sama dengan 0,
Ni.
0.
Yalah.
Yang tu apa tu?
Ini apa? Okay, because they give you, I just write here, they give you the elevation difference between point 1 and point 2 is 5 cm. This is Z1 minus Z2 0.05 lah. 5 cm ni in meter. I change this in meter. 0.05. This one is used when you nak kira kat sini. Nak kira
So Z2 tu 0
Z2 is 0, yes.
Oh, okay.
Because this is my reference point. I take my reference point at point 2. So this is 0. And at point 1, this is 5. So the difference between Z1 and Z2 is 5 cm or 0.05 meter.
Okay, baik sir.
Okay. Okay, anything else? Tak ada? Alright. So it's just ni lah kalau ada angle ni maksudnya you ada komponen X and komponen Y. So itu je yang membezakan dengan soalan yang tadi kot. Ni tak ada tak ada angle Okay. Last one kot dah 1.5 lah. Okay, last one. A jet of water is deflected by a stationary vane. So this is your stationary vane yang berlorek ni. As shown in figure 4, the jet speed and diameter are 25 meter per second. Okay, the V1 enter at 25 meter per second, and the diameter of A1 is 25 centimeter. Okay, so you can find your A1. Okay, berapa? If the jet is deflected 60 degree, okay, this is your angle, determine the force exerted by the jet on the vane. Okay, so they ask you to find the force exerted by the jet on the vane. Okay, so you have V1 and masuk, okay, label your V1 and you have label your V2. Okay, in this case the label V2. So you have two component. So this is V2 x cos theta, and this is V2 y sin theta. Okay, the angle is here 60. Okay. Okay, so V1 tak adalah, V1 je. And there's no pressure mentioned. Okay, so this is quite easy lah sepatutnya. Okay, you have A1, this one equal to pi times 25 bahagi 2 12.5 So 0.125. Okay, squared. And okay, that's it. And then this area is the same lah, so it's just the same the same jet water. The cross section of this point and this point is the same, so area tu pun pi times diameter jugalah, 0.125 square, radius dia square. Okay, so you have the V1 25 meter per second. Okay, you can find your Q. Okay, from continuity equation you can find your Q, A times V. Okay, you have the A1 and B1, so this will be pi times 0.125 squared darab dengan 25. So this is your Q. Berapa nilai Q?
1.227.
1.227, 1.23 lah. I like to take only 2 meter decimal place. Okay, but it's up to you lah. But you need to be consistent. Okay, that's your Q, and then you can use your linear momentum equation. Okay, to the right positive, and this is your reference axis. Summation of force in x direction equal to rho Q times V2x minus V1x. Okay, and you only have Rx lah, in force you don't have pressure force, and you have the W, so only Rx. Okay, only Rx. Okay, Rx kanan positive. So this equal to 1000 of water times Q 1.23 times V2x. V2x is V2 cos theta. I forgot to write this. So V2 cos theta. Okay, this is the same direction to your x. Okay, and minus V1x, so this will be V1x in the same direction, so that's why only V minus V1. Okay, so you can substitute everything. Okay, V2 ni berapa V? 25 lah, 25 kan. So this is the same area, so the V is the same. V1 and V2 ni sama lah. Okay, 25 cos 60 tolak 25. Ya, darab 1.23 darab 1000. Berapa nilai ni?
Negatif 15,375.
15,375 unit
Newton.
Okay, sorry, Newton. And okay, again this is negative. That means your Rx is something to the left, not in this direction, to the right. Okay, and do the same for y. So first you take y upward is positive, Fy equal to rho times Q V2y minus V1y. Okay, and you only have y term lah, so there's no P1 or W, so only Ry to the upward Ry. Okay, equal to 1000 times 1.23 times V2y is this one, V2 sin theta, and it's moving opposite direction to your reference, so you need to put minus. V2 is 25 sin 60 minus V1y, so there's no V1y, 0. So berapa nilai dia? 1000 kali 1.23 kali minus 25 sin 60.
Negatif 26,630.
26,630
0.28.
point
28.
0.28 juga. Okay, Newton. So again it's a negative, So that means this assumption upward is wrong. The ry should acting downward lah. Okay, so it's your ry. Okay, and so they ask you to determine the force exerted. So this one is exerted force lah. Okay, you need to in both direction. They don't ask you to find the resultant force. They ask you to find the force. Okay, in x and in y. So this in x and this is in y. Okay, sama jawapan dia. And this is quite simple. So that's why you get only 6 marks. Okay. Any question? Anything that you don't understand or you want to ask? Ada? Tak ada? Okay? Did everyone understand this? Understand pun tak ada, tak understand pun tak ada. Macam mana?
InsyaAllah sir.
Huh? Okay, I hope you understand lah. I hope you know, understand, you get it, how to solve this question. Okay, and now already 1:40. Nak buat ke? Nak buat lagi ke? I think we can continue this in the next class. Okay, I think we have too much today. 2 hour session is not productive one. Okay, I think we can end our class. Okay, our tutorial. I will post this slide in the Google Classroom, and also the video lah in my YouTube. Okay. Okay, if you don't have any more question, okay, thank you for those who has submitted the assignment. I think every one of you has already submitted the assignment. Well done. I will check lah after this. And have a nice weekend, and we shall meet again on next week, next Wednesday. Okay. With that, Assalamualaikum warahmatullahi wabarakatuh.